Hello, everyone. Today, we are going to talk about something called the interstellar medium and star clusters. Now, the interstellar medium, what this means is, let's think about it. Let's break these words down. Medium. You know what medium is? We talked about medium once before, so some months ago. Medium, we're not talking about halfway between large and small. We're talking about material, stuff, medium, stuff. Remember, a wave has to move through a medium. To be a wave, it needs a medium. It's the stuff. Inter, meaning between. Stellar, stars. The stuff between the stars, which I'd like you to write down, the main stuff between the stars, and that is dust. Write down dust and write down gas. Now, let's take a look here. This is actually a picture that John, our assistant for section 4213, not Joe, but John. Joe takes pictures too, but John is the main photographer guy in Astronomy 12. He got this great shot of the Milky Way, and he made this slide with pointing out some dust areas, some gas areas. So let's talk about first dust. So we'll talk about dust. A couple things to write down. If you have smaller accumulations of dust, it scatters light from stars. It scatters or reflects light from stars, and it's called a reflection nebula, and it's bluish. I'm going to say that again. If you have smaller accumulations of dust, it scatters or reflects light from stars, and usually the size of this grain of dust scatters blue light. It's usually blue. So it's called a reflection nebula. So you see the blue area there? That's a reflection nebula. So call that, so what do you need to know? Reflection nebula, it's smaller accumulations of dust scattering light from stars, and they're usually bluish in color. All right? Let me show you some more reflection nebula. Well, the red here is not, but you see the blue over here, a little bit of blue, reflection nebula. The Blue Horsehead Nebula. You kind of see a horse's head, kind of like the nose down here, actually the whole snout. Right over here, there's the eye. Here's the jowl, the jaw. Look at that, what is it, the forelock? The little hair on the top of its head, not the mane. But the forelock, I guess they call it forelock, not furlock, forelock. I don't know. Someone told me that once. Believe me, I'm not a horse person. I really know nothing about horses. So I apologize if I'm offending any horse people out there. So yeah, it kind of looks like a Doberman's also face or head. So this is the blue horsehead. You don't have to know that, but that's blue. If I were to mention, if there's a nebula that looks kind of bluish, what is it? To know it as a reflection nebula or bluish in color. Look at this one. Here's one. Bluish in color, reflection. The witch's head. You don't have to know the name, but look, blue. And you see it's kind of like a witch's face mask where there's the nose and mouth, chin kind of staring up to a Rigel, kind of looks like a mask of a witch. So that's the witch's head. And let's go back here. And let's go back to this. Now, so reflection nebula, bluish in color, smaller accumulations of dust. But you could have a large accumulation of dust. So this is a separate thing now. So still dust. If you have larger accumulations of dust, it blocks light from behind. It actually absorbs light. It's dark in color. And it's called a dark or absorption nebula. Again, I'll say it again. Dark or absorption nebulae, just plural for nebula, is when you have a lot of dust blocking out light from behind. And it appears black. They're very, very dark in appearance. So look at this. See these veins? It's actually called the Trifid Nebula. We have this part meaning reflection, but look at this. See the black over there? That's actually dust. Small grains of iron and carbon, stuff that stars create. Iron, carbon, silicon, even ices would be considered grains of dust, little pieces of ice. But there it is, the dark area there. It's called a dark nebula or absorption nebula. Dark or absorption nebula. It's dark in appearance, or usually black in appearance. You notice one right here? Actually, you know what? For an example of a dark nebula, I'd like you to know an example of a dark nebula, and this is our absorption nebula. This is the main one. It's the Horsehead Nebula. The Horsehead Nebula is an example of a dark nebula. I'd like you to know that. And you can kind of see it's a horse's head. Look, you know what I kind of see here? Look what I see. It kind of looks like, well, some people say it kind of looks like a knight in chess, a little knight piece, a little horse. Some people say, it looks like a seahorse head. Yeah, it kind of looks like a seahorse head. But what I see now is this. It's a whole horse walking away. And look at this. There's the butt of the horse. Imagine a horse walking away from you. There's its butt. There's its nice long tail. The horse is walking away. And you say, hey, horse! And the horse turns around and looks at who yelled horse. So you see that? Can you see that? It's like a whole horse's body. The horse is walking away. There's his butt. There's his tail. And there's the head turning to look after you yell at it. I don't know if you're seeing this. Doesn't matter. Just know the Horsehead Nebula. That's good enough. And the Horsehead Nebula is a dark or absorption nebula. Now, I see some dark nebula in here too. Aside from the reflection, you see the black and brown areas. That's dark nebula or absorption nebula. That's actually just a void in this reflection nebula, just an area where there's really not much. Maybe some dark there. I don't see much. Now, we're done with dust. Let's talk about gas. So the most common type of gas that we have out there is hydrogen. It's good to know that. So it's mostly regions of hydrogen. Now, if we have cooler regions of hydrogen, they're called H1 regions. And these H1, it looks like HI. It's a Roman numeral 1. H with a Roman numeral 1. They look like high, but it's really H1. These are cooler regions of hydrogen, not what I'm showing here. I'm not showing you an H1 region. You can't even see H1 regions because they're so cool they don't give off visible light. So you're talking about gas, which we are right now. The cooler regions of hydrogen are called H1. Looks like it's a letter H and then the Roman numeral 1, which looks like an I. H1 regions, and these are not giving off light. So you know what they give off actually? Radio waves. You need a radio wave telescope to see these regions or to pick up these regions. So an H1 region, you cannot see with visible light. You can only detect with radio waves. So you need a radio telescope to see these regions. And this is not one of them. This picture right up here, ignore that for now. That's the Trifid Nebula. We'll talk a little bit more about that. We already talked about it. So H1 region, you cannot see, only it gives off radio waves. But there are other types of hydrogen gas regions, mostly hydrogen, that actually do give off light. And those are called H2 regions. H with a Roman numeral 2, look like two eyes put together. H2 regions. These are warmer regions of hydrogen gas, and these do give off light. And what we're going to do is we're going to break them into some categories here. We're going to break them into 3 different categories, these H2 regions. So the first type of H2 region, and here's actually one of them, the red right here, but I'm going to use this as an example. An emission nebula. We talked about emission nebula. Now look, there's an emission nebula too. If we go back here, if I can go back, which for some reason I'm not going back. All right, well, this is the Orion Nebula. I'd like you to know the Orion Nebula is an emission nebula. What do you need to know about an emission nebula? Well, it's a place where stars are being born. It's the birthplaces of stars. Actually, stars have already been born in these areas, and that's what's heating up the cloud. And what color are emission nebulae? Reddish in color. So for H2 regions, one I want you to know, one type is called an emission nebula, birthplace of stars, reddish in color. Example, Orion Nebula of an emission nebula. You can write that down. Here's a great picture of the Orion Nebula. And look in here, there's also reflection nebula, some blue here. There's some dark nebula there. Remember some baby stars in here, stars that have been born. It's beautiful. Reddish in color, hydrogen glows red. So that's good to know. Another emission nebula. You don't have to write this down. We're still talking about emission nebulae. Look at this one. All red. You see red out there? A bunch of red? Emission nebula. But look, does this look like something? West Coast. Look at that. Here is Baja. Here is, look, Florida. There's actually Mexico, all Mexico right here. Here is the East Coast. Here is St. Louis. Here's, I don't know what that would be. Charleston, Charlotte. Look at that. That looks like it could be Salt Lake City. This looks like North America. It's called the North American Nebula. You don't have to know this, but it's an emission nebula. So there's an good emission nebula. Oh, gee. Yeah. Okay. This picture was ruined by, I think, Joe. I called it, how do I get rid of, let me see here. Oh, gosh. I'm stuck with Joe's I'm stuck with Joe's mess here, my nice picture. I can't even get rid of it. I called this the Cow Bear Nebula. It looked like a bear's body with like a cow's face, but it's been ruined. Because look what Joe put on here. He didn't like that I called it the Cow Bear Nebula. You don't have to know that anyway. It's not really known as the Cow Bear Nebula, but it looked like a cow with a cow's face and a bear's body. And Joe hated it when I put two animals together. But you know what the real name of this thing is? It's New General Catalog 346. It needs a name. It needs like a name, like a real name. Like the cow bear, or at least the bear or something. It's an emission nebula, but with some dark nebula in there. But I decided to name it, and Joe was not happy with it, so I'm stuck with this. If it were my real PowerPoint here, that no would not be there. I can't get rid of it. It's a little upsetting now. I'm going to move on. That's what Joe told me to do. All right, move on. Moving on. Here's the cone, emission nebula with some dark nebula. Now here's another type of H2 region. We're moving on from emission nebula. Look at this. It's the ring nebula. Remember what that was? Planetary. So I'd like you to know what a planetary nebula is. Well, really, it is. It's a dead giant star, right? That burped off its outer layers. So the ring nebula is an example. I'd like you to know that example of a planetary nebula. A planetary nebula is another H2 region. It's not just hydrogen. It's actually multicolored. Why is it multicolored? Different gases are there. Remember, a star died. It created a whole bunch of heavy elements in gas form. Also, usually spherical, usually circular, some shape like that, with what's at the center. What's at the center of a planetary? A white dwarf. So if I on a test say, hey, astronomers have found an object, it's circular, it's multicolored, and there's a white dwarf in the center, what is it? Well, you better pick planetary. It's a planetary nebula. And this one happens to be the ring nebula, but this is its proper name. So I'd like you to be able to, if I describe something to you in words on exam 4, I'd like you to be able to tell me what it is. So if I say something spherical, multicolored, it's gaseous, and it has a white dwarf at the center, it's a planetary. Well, look at this one, the helix. Nice planetary. Look, white dwarf at the center, multicolored. Another planetary, cat's eye. Another planetary. Don't even remember the name of this one. Another planetary. Sometimes they're like in bow tie shape, but the white dwarf is at the center. And now here's another H2 region. Not a planetary nebula, but a supernova remnant. Supernova remnant. That's good to know. A supernova remnant. How is this different than a planetary? Well, look at it. Again, it's from the death of a supergiant. It's a supernova, right? So it's more violent. It's chaotic. It's more wispy, more web-like, veiny. What else? I wish I had you guys to help me out here. That's probably good enough. Violent, wispy, vein-like, web-like, chaotic. I don't know. Well, what's not at the center? There's no white dwarf. But you know what we would find the center if we got up close? We would find either a neutron star or a black hole, right? A pulsar, neutron star, pulsar, or black hole. So that's what would be at the center of a supernova remnant. Look at this one. This kind of looks like, I don't know. It looks, kind of looks like Africa, kind of curled up at the bottom. See how, look at this, wispy. Look, web-like, chaotic. Notice thing shape. It's a supernova remnant in the Large Magellanic Cloud. Look at this. Oh, God. This was my, that I called the pig bat. But again, now look, I mean, you tell me if this does not look like, well, at least a bat. It's the Vela supernova remnant. Look at the head of the bat. Look at the legs down here. There's the tail kind of flying towards you, a wing over here, a wing. Doesn't that look like a bat? But no, Joe can't handle that. Did I call it something? I guess because I called it a pig. I said it's a pig bat. Look what he did to it. Move on. Again, I can't get rid of that. They're really annoying right now. Kind of like handcuffed here that I can't do with anything. But that was a good shot that Joe ruined. All right. Oh, here's a supernova remnant from the supernova that we saw in 1987 in the Large Magellanic Cloud. All right. Done with that. Let's go to star clusters. All right. Make a title on a new page, new sheet, new region, whatever. Star clusters. Star clusters. Now, one type of star cluster is called an open star cluster or galactic star cluster, found in the plane of the galaxy, like the flat part of the galaxy. And an example of a open cluster I'd like you to know is the Pleiades. 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 Or the Seven Sisters. Or in Japan, you know what they call it. Subaru. This is it. It's called different names. In some Native American cultures, called the Six Wives Who Ate Onions. And there's a great story. Justin, who teaches with me, tells this story pretty well. I think I think he does. It's called in Argentina the Seven Goats. It's called the Seven Sisters in different places. But I'd like you to know it as the Pleiades. And look what's around these stars. Dust. This is a reflection nebula. These are younger stars. They're like 200 stars in an open cluster. Write this down. Anywhere from about 10 stars to a few thousand in open clusters. And the Pleiades is, I think, the example that you should need to know. And these stars are relatively young stars of all types. But just know, what do you need to know? Pleiades is an example of the open cluster. The Pleiades is an example of the open cluster. Anywhere from 10 to maybe a few thousand stars. And the stars are relatively young. Young stars. Young stars. Let's see some more open clusters. Not very exciting here. Definitely not a good picture. That's a nice picture. So open cluster with different color stars there. All different types of stars, O through M. Now this is a type of cluster called a globular cluster. And these are found around the galaxy in what is called a halo. Not the flat part, but like north and south of the galaxy, above and below the plane, and what is called the galactic halo. These are the globular clusters, Globular. Now, if I can go back to open clusters, it's working now, they have no shape. Open clusters, they have a shape, but there's no distinct shape. One cluster, open cluster, does not look like any other open cluster. That's good to know. But look at the globulars. Guess what the shape of the globulars are? The shape of the globulars, now this is not going back. The shape of the globulars are glob-shaped. So globulars are ball-shaped or globs. They have, they're anywhere from, this is good to know, 100,000 to 1 million stars. And the stars are very old. 10 billion years old. Probably on average 10 billion years old. They're not the O stars and B stars. They are the low massive, usually red stars, red dwarfs, yellow stars, some orange K stars. Not seeming to go back here. But these are globular clusters. And so there's a nice one. Let me see some other. Look at this beautiful shot of a globular. Now remember, if it's a glob shape and have a lot of stars, it's a globular. If it's not in no distinct shape and it doesn't have as many stars, that's an open cluster. So here's the globular, and another globular, and sometimes we see blue stars in there, which is kind of weird. There shouldn't be blue stars, O and B stars in a globular, but because sometimes they strike each other, the stars in a globular cluster are so close together, sometimes they hit, and they get really hot when they collide. They combine, and when they get hot, they get blue. They're called blue stragglers. Oh, here's an exercise. Now it's letting me go back. It wasn't before. But do you guys want to do this exercise? Look, no, you don't. Well, maybe you do. If you want to do it, do it. You don't have to do it with me. I'm about done here. You can do it on your own. Just for practice. See if you can get, what these are. And Yeah, you don't have to do this, but if we were in class, we'd be doing it. I already gave you credit for this exercise. What did it say? First part, I can't even go back now. I don't know what the heck's wrong with this. But, yeah, that's it. That's it for interstellar medium and star clusters. And hope you guys are doing all right. I'm going to turn this thing off, and we will talk to you next